This video will be about similarity. So you can use similarity to compare any sets of two things that are related. For example, a child's age and their height is related. The older you get, the taller you get. And when we compare these things, we use a proportion. So when we set up our proportion, we want the top two things to be related somehow. So if we want to take that child's height and age example, the age of the first child they give you would have to relate to the age of the second child they give you. The ages are related. Then we have to compare the heights. So age over height, well, this would have to be the height of the first child. These two also have to be related. And same thing, these two would have to also be related. This would have to be height of the second child. And then the heights would have to be related. So going kind of in a box, everything has to relate to each other. So for example, a piece of cable 8.5 centimeters long weighs 48 grams. How long will a cable be that weighs 106 grams? So this is cable 1. Let's use that to set up the left side of our proportion. The first cable was 8.5 centimeters long. 1/2 is the same as the decimal 0.5, so 8.5 over 48. So we did length over weight. We've got to do the same order for cable 2. Now all we know about cable 2 is the weight. So it was length over weight. We only know the weight is 106. Whatever empty spot exists will be where we put our variable. So once we've set up a proportion, to solve it, we cross multiply. We do 8.5 times 106. And we do 48 times x. So 8.5 times 106 is 901. And 48 times x is just 48x. Now to get x alone, we have to solve this equation. This is 48 multiplied by x, so we do the opposite of multiplication, which is division. So 901 divided by 48 is 18.7708. Let's round to the nearest tenth. So this would become 18.8. So now let's look at the second example. It's very, very similar. We have an 8.5 foot long cable, 8.5 centimeters long cable. Still weighs 48 grams, but this time they tell us a length. So we can start the setup the exact same way, 8.5 over 48. These are both the values from the first cable. But then we know the cable is 13 centimeters long. They gave us length. So this time the 13 will be the top of our fraction, and that leaves the bottom to be x. We have to place these correctly, or else the problem will come out incorrect. But once we've placed them, we solve them the same way. 8.5 times x equals 48 times 13. 48 times 13 is 624. And then to get x alone, we divide both sides by the number in front of x. So 624 divided by 8.5 is 73.41. Rounding to the nearest tenth again would be 73.4. Let's do one more example. The ratio of men to women at an office is 5 to 3. If there are 400 men, how many women are there? So same idea, we still set up our proportion. This time they said ratio, but they told us exactly men to women. So the 5 to 3 would be the left side, and we know it's men to women. So men on top, women on the denominator. So if there are 400 men, we have to place them in the same order. Men in the numerator, women in the denominator. So 400 in the numerator. And our empty spot is our variable. Once you've set up your proportion, we cross multiply. 5 times x is 5x. 3 times 400 is 1,200. And then divide both sides by the 5. So when you have problems with these similar things, they give you one set and then part of the second set, you're going to follow this same pattern over and over. Set up a proportion, cross multiply, and then divide to solve. So that concludes our discussion on similarities.